Okay, here's our practice quiz. 5-1 to 5-3. Remember that in class we did an equation, solving an equation problem. So we're not going to do one, there's not one on here, but that is on the quiz. Okay, so you've got your reference sheet, and you're going to look at your sheet, and you're going to find the formula that matches the pattern that we have right here. So we've got sine, cosine, cosine, sine. If you look at your sheet, that's one of your sine formulas. So then you decide, okay, is it the sine for adding two angles or for subtracting them? And this one is for subtracting. And the angles we're subtracting are 18 and 13. So the answer to the problem is just sine 5. That's it. That's sine 5. You don't do anything with that. That's just it. Same thing here. We have tan 27 minus tan 20 over 1 plus tan 27 tan 20. Well, that's a tangent formula. If you look on your sheet, that's a tangent formula. So you have to figure out, okay, am I adding or subtracting my angles? And this combination of signs is a subtraction, and the angles are 27 and 20. So this is a formula for the tangent of 7. That's all there is to it. C is cosine cosine minus sine sine. And that is a cosine formula. Well, which one is it? Well, cosine cosine minus sine sine is actually the plus formula. Your angles are 53 and 33. So this is a formula for the cosine of 86. Perfect. All right, cosine 195. First thing we do is figure out two special angles that will add up or subtract to 195. Now, I'm not here to collect your ideas. I'm sure you have an idea, and there's a bunch of different ideas. So I'm just going to have to go with one. So I think I'm going to pick, how about 135 and 60? Now, I don't want you to be confused. We talked about this the other day. 135 is special. When we say special, we think about 30, 60, and 45, for sure. But 135 is special because 135 has a reference angle of 45. So any angle, no matter how big it is or where it is in the coordinate plane, if it has a reference angle, in other words, if you draw your triangle and that little angle right there is 30, 60, or 45, then you're all set. So here's my 135. I know that's 1, that's root 2, and this is negative. A couple of you have already turned in the homework for this section, 5.3, and you have to be careful when you're not in quadrant 1, make sure you're including your negatives. The other angle in the problem is 60, so I'm going to go ahead and draw 60. It's going to look like that. And now I'm going to get my formula. I'm going to look at my reference sheet, and I have cosine angle plus angle. So cosine angle plus angle is cosine of the first, cosine of the second, minus sine of the first, sine of the second. Now I'll just look at my pictures and plug in all these numbers, and that will be the answer to the question. So cosine, negative 1 over root 2, or rationalized negative root 2 over 2. Cosine 60, 1/2. Sine 135 is actually positive 1 over root 2. And sine 60 is root 3 over 2. So it looks like my answer, if I multiply each pair, and then write it all as one fraction, looks like that is my answer. And if you look back at your notes, that looks real similar to the answers we got before, because those are the numbers we keep using over and over again. Okay. Now we have one very similar to the one we did in class today. We have to verify this. Now, I hope you remember from doing this earlier that sign does not distribute, but you can use one of your formulas, one of your identities, to stretch this thing out. So, sine of the first, cosine of the second, plus cosine of the first, sine of the second. Again, I have my identities memorized. You do not have to memorize them, but you have to be able to use that reference sheet. So this is your U and your V. Sine U, cosine V, cosine U, sine V. Now, 90 is indeed one of our it's very special. 90 is on our unit circle, right here. So remembering that cosine is 0, or cosine is x, and sine is y, we can fill in a value for sine 90. Sine 90 is 1. Cosine 90 is 0. So 0 times sine, that's gone. And all we have left is 1 times cosine, which is exactly what we were hoping to be left with. All right, now we have another verified problem. So cosecant x minus cosine x, cotangent x, equals sine x. Well, this is a big mess, but we're not going to be frightened by it. We're going to do what we know how to do. So we know that cosecant is 1 over sine. So I'm going to change that into 1 over sine. Cosine is nothing but cosine, so I'm just going to leave it cosine. But since that's a fraction and this is going to be a fraction, I'm going to go ahead and make that cosine over 1. You do not have to do that, but when I have a bunch of fractions in my problem, it helps me keep things lined up if I put them over 1. Okay? So cotangent, cosine over sine. Now, please don't try to cancel anything. I guess nothing cancels anyway. But what we have is 1 over sine minus cosine squared over sine. Well, they already have a common denominator. If they didn't, and a lot of times they don't, we have a lot of examples where they don't. If they didn't have a common denominator, we'd get a common denominator, but they have one, so we're all good. So we have 1 minus cosine squared all over sine. Guys, when you combine two fractions, when you add or subtract two fractions, the common denominator stays. It doesn't disappear, it doesn't get doubled or squared or something weird. It's just, 1/5 plus 2/5 is 3/5. The denominator just stays the same. So now we have 1 minus cosine squared. That needs to ring a bell. Since sine squared plus cosine squared is 1, 1 minus cosine squared is sine squared. So this is sine squared over sine. Now we can cancel, and that's just sine, which is exactly where we were hoping to end up. All right, so, some of these ones we've done together, some of these identities we've done together, go back and try to work through them again on your own. Go through the steps, factor, common denominator, whatever it is that you're doing. But please do remember, 1 minus cosine squared is sine squared, and 1 minus sine squared is cosine squared. All right, we got one more problem to do, and this one looks horribly scary, but it doesn't need to be. Here's the given. Tangent is 4/3, and tangent of x, and x is between 180 and 270. Secant y is negative 13/5, and y is between 90 and 180. And we're going to find the cosecant of x minus y. All right, so let's just start at the beginning. Let's draw a picture of angle x. Angle x is in quadrant 3. This is a fancy way of saying 180 to 270, that's quadrant 3. And the tangent, opposite over adjacent, is 4/3. But be careful, those are both negative because of the location. Because of being in quadrant 3, those are both negative. Now, where's this one? Well, it's between 90 and 180, so that puts it in quadrant 2. And the secant, which is reciprocal of cosine, is 13/5, so the cosine is 5/13 adjacent over hypotenuse. Notice I put the negative on the 5 because the hypotenuse is never negative. X can be negative, y can be negative, but not the hypotenuse. Okay, for both of these triangles, let's do the Pythagorean theorem and come up with the third side. So this one you probably recognize, 9 plus 16 is 25, so that's just going to be 5. This one, we want to know what this is. So 5 squared plus y squared is 13 squared. A squared plus b squared is c squared. So y squared is 144, and it looks like y is going to be 12. And again, because of location, that y is going to be positive. It's definitely possible that sometime it would be negative, but it is positive in this case. Okay, so now I have a picture that I can find whatever information I need about x and y, I can find now because I have the picture. So what do I want to know? I want to know the cosecant of x minus y. Now if you look on your reference sheet, you do not see a cosecant. However, you do see a sign. So I'm going to go ahead, I'm going to put an orange box around this to remind myself that this was my problem. But I'm going to go ahead and think of it as sine x minus y. And now I have a formula for that. So it's sine x cosine y minus cosine x sine y. So I do not have a formula for cosecant, just like I don't have a button on my calculator for cosecant. So I do it as 1 over sine, or reciprocal of sine. So I'm going to go ahead and do this problem as a sine problem, and then whatever answer I get, I'm simply going to turn it over. So, what answer am I going to get? Well, I've got to plug in these numbers straight from my picture into the formula. So, sine x, this is x, this is y. So, sine x is negative 4/5. Cosine y is negative 5/13. Cosine x is negative 3/5. And sine y is 12/13. I drew a picture of x and y based on the given. And now I am just plugging in the sine and cosine values straight from the picture into the formula. Okay, so what do I get here? These two are multiplied, so that's 20 over 65. Now I got a double negative, so that's actually going to be a plus 36 over 65. Which gives me an answer, they have a common denominator, which gives me an answer of 56/65. Now, that is the sine. Remember this right here though? We wanted the cosecant. So the cosecant will be 65/56, the reciprocal of the sine. on this old quiz that I copied, that was a bonus question. That type of problem will not be a bonus for you. That type of question will be something you'll need to do. So, just to review, because it looks so big and scary, draw a picture of your given. You're going to know where to draw it. It's going to tell you in the given where to draw it. Make sure you put in whatever negatives you need. Write out the formula you're using. You'll be using some formula, may not be this one. And then take the numbers from the picture and plug them into the formula. All right, that's it for the practice quiz. Good luck.